Hello, my name is Jose Donner. Today I'll be showing the circuits for experiment number 8. Now we start with 7493, so this is part 1. First we have our clock signal coming here from this black cable all the way here to pin 14, our chip. We have the clock signal, well, in this case it's the input signal, the output signal from our first bit is coming over to this other pin, which is pin 1. On pins 2 and 3, we have ground connected to the MR inputs because we're not setting anything on the circuit. We also have power over here. We also have our outputs for the chip. So this is our second bit. So where you can see it. So this will be the second bit. The blue cable right here with this white one that we showed before is going to our first bit here on the LED panel. We have also this red cable. This is pin number 8. This is going to our third bit, and this other blue cable, this little squarish, this one right here, some pin 11, is connected to the fourth bit. So if we test this out, we can see that it's counting in binary. So let's show it from the beginning. So 0, 1, 2, 3, 4, 5, 6, 7, and so on. So yeah, that's it for this circuit. Now we proceed with our second circuit for part 2. We have the same chip as before. Now we have our overrides connected. Well, this is a signal from QA, which is also being classed as a clock signal, but it's also passed to our override by this orange cable. We also have on this ground cable, we have our most significant bit, which is this same cable. So as we see, both blue cables right here are connected to our overrides on the chip. So when we test out the circuit, we will see that it would restart at 9 because we have our overrides connected to this bit and this bit. So 1001 is 9, so it's just restarting when it should be 9 because this is an asynchronous override. So it just becomes 0. Now we proceed with the mod 60 counter. On the left, we have a counter which is mod 10, which is being cascaded to a mod 6 counter. So first let's show the chip on the left. So this is 7490, which is connected by this white cable to our clock signal here on the board. We also have the output from, because this has 2 flip-flops in and of itself, so we have the output of the first one being to the clock of the next inside of the chip. We have all of the overrides connected to ground. We power up the chip over here by this green cable, and we ground it here on the other green cable on the top. We have all of our outputs then going to these 4 LEDs as shown over here. The output of the fourth, or the most significant bit of this chip, is being also passed over here, so we can cascade them both. So whenever this one clicks and the counter resets, we will get a tick from this counter. So over here proceeding to the right, we can see that this is modified to be a mod 6 counter because we have the outputs from, if this is least significant bit, this most significant bit, we will reset at 6. So whenever this LED and this LED are on, so this is white and green cables, whenever both of them are on, we can see that by this brown and red cable, this is the white one and this is the green one. So these are passing here to the override. So whenever both of them are on, it's gonna reset. We also have these overrides, which are clear, our load inputs, we're having them grounded. We have power also and ground as well. Now let's show of the clock ticks. So we wait until the restart here at 9. Now we should see a restart as shown. So that's it for our last circuit.